Hooks a trout and reels in his line at 4 inches per second. Assume the tip of the fishing rod is 12 feet above the water and is directly above the angler. Now he looks kind of uncomfortable holding that fishing rod, but anyway. And the fish is pulled in horizontally directly toward the angler. Find the horizontal speed at which the fish when it is 20 feet from the angler. Now, again, this time we're talking about a triangle. We're going to be looking at the construction of a triangle. And we're not really concerned about area here, are we? The area is changing and the angles are changing, but that's not really what we're concerned about. What we're concerned about in this problem is the rate at which the sides of the triangle are changing. Now, it just so happens that our angler was courteous enough to reel it in for us to form a right triangle. So we could be thankful to him for that, because that makes the problem easier. Because as far as lengths of sides and right triangles are concerned, what do we have that helps us find lengths of sides when we're dealing with right triangles? The Pythagorean theorem. So we're going to have a squared plus b squared equals c squared. Now, as far as this problem is concerned, I'm going to let a represent horizontal, b is going to represent vertical, and c will represent the fishing line, which would be the hypotenuse. Are y'all good with that? All right. Now, from this, it's a squared plus b squared equals to c squared. Okay, let's take the derivative of this. The derivative of a squared is 2a d dt plus 2b db dt. Sounds like a robot on the 80s sci-fi show. Alright, that was lame. 2c dc dt. Okay. Now, from this we can start plugging stuff in. We've got the derivative. Let's start plugging stuff in. Alright. 2 times a, and a is horizontal. What do we know as far as the horizontal side is concerned? It's going to be 20 feet. We're concerned about when the fish is 20 feet from the angler. Alright. dA dt. From the problem, what are we concerned with? We don't know it, do we? In fact, that's what we're trying to find. So I'm going to write dA dt here. Alright. Plus 2 times. Alright, what's b in this case? 12, yeah. Now, at what rate is that changing? What? It's not changing, is it? It says the angler is consistently holding, this is sign language for consistently holding, the fishing rod 12 feet above his head. So it's not changing, so I'm going to have a 0 right there. Equals to 2 times, alright? Now, what is my c value here? The length of my line. I don't know it, do I? Alright, what rate am I pulling in the line, though?
4 inches per second.
Yeah, 4 inches per second.
1/3.
Ah, very. Yeah, everything else is in terms of feet, so yeah, I guess we do need to write that in terms of feet. So what did you say? 1/3 of a foot per second? Good deal, because in a minute I was going to get an answer that didn't really make sense. So I'm glad that you spotted that. So I've got 2 unknowns here. dA dt I know I'm wanting to solve for, because that's what the problem asks. But what about that particular C value? Yeah, I'll just go to the Pythagorean theorem to find out what C is when this is 20 and this is 12. So I've got 20 squared plus 12 squared equals C squared. So it's going to be 400 plus 144 equals C squared. So C will equal to 544. Is that a perfect square?
No.
It's not, is it?
23.3.
Alright. But I'm going to list it as the square root of 544 for the purpose of working the problem. In the end, when I get my final answer, I'm going to take it out to 4 decimal places. But for right now, I'll call it the square root of 544. Is there a question there? Alright, so now we can get on to solving the problem. Alright, this term right here goes and plays with the dodo birds. So we're left with dA dt is going to equal to 2 times the square root of 544. Now if you pull this 3 to the denominator here, it'll be 2 times 3 times 20. And those 2's go away. So we've got the square root of 544 divided by 60. Say that again?
0.3887.
That'll be in terms of feet per second. So this is about a third of a foot per second. So this is a little more than a third of a foot per second. So that's what we come up with as our answer.